So hello everyone, welcome you all to this new video. So in this video we are going to continue with the problem, one problem which was pending in the previous video that I couldn't do it. So about Green's theorem. Okay, let us continue with the problem. One problem is already solved in the previous video, please go and watch it. Second question, using Green's theorem GT, evaluate the closed line integral 3x square minus 8y square dx plus 4y minus 6xy dy, where C is the boundary of the region enclosed by the parabola y square is equal to x and x square is equal to y. Okay, so they have given two conditions here. One is for two parabolas, one is y square equal to x parabola and x square equal to y parabola. So according to that we should be drawing the plot right first, as I've told you. Plot drawing is very must. First you should be drawing, you should be knowing how to draw the plot. Since they have given two parabola, first let us write the parabola of y equal to x square. Okay, that is, this is y axis, x axis, right? So this is the parabola of y equal to x square, where we would be checking for different values of x, okay, positive as well as negative. The resultant would be equal to y. And next parabola is of x equal to y square, okay, that is here. This is the parabola of x equal to y square. Now again I have told you, intersection, wherever the two parabolas intersect each other, that region you should be shading. Okay, this is the intersection region. Okay, and from the x axis point till the y axis point we should be drawing one perpendicular line, okay, in order to get the limits of y. Okay, this much is done, right? Now let us solve the problem and let us see what we would be getting. Okay, first apply Green's theorem using GT, that is Green's theorem, that is closed integral m dx plus n dy, right? So here m, in place of m what we have here, 3x square minus 8y square, and in place of n what we have, 4y minus 6xy, right? So dou m by dou y, what we would be getting, because in the formula we have this term, right? So dou m by dou y is equal to partially differentiating this m with respect to y. So here we don't have any y term. Here we have one y term, that is differentiation of y square is 2y. So minus 8 into 2y is minus 16y. Similarly, dou n by dou x, this term n with respect to x now. So here we don't have any x term. Here we have one x term. Differentiation of x is 1. We are left with minus 6y. Okay. Now, according to the formula, we have this part here to simplify, that is dou m by dou y minus dou n by dou x, that is minus 16y minus 6y. If you solve it, you will be getting answer as minus 22y, right? Or this, it is the reverse of that. So we have done one mistake here, that is dou n by dou x minus dou m by dou y. It is according to the formula, it is like this, right? So it should be minus 6y minus of minus, so this should be plus. So we would be getting answer as 16 minus 6, that is 10y. Okay, not 22y, minus 22y, sorry for that. The answer is 10y. Now point of intersection. Check for the point of intersection. That is, we have two terms, that is, one is y is equal to x square and x is equal to y square, right? So if you want to equate this part here, x equal to y square, so what we could be doing is put square root on both sides. That is, we put square root on both sides, square root and square root would be getting cancelled, so we would be getting y is equal to root x. So we have one y equal to x square and y equal to root x, so we can equate x square is equal to root x. Okay, After that, again, if you want to remove this square root, again put square on both sides. So root and square would be getting eliminated. We would be left with x to the power 4 is equal to x. Or we can simply write it as x to the power 4 minus x equal to 0. And take x common, we would be left with x cube minus 1 equal to 0. Okay, and if you solve these two equations, we would be getting x is equal to 0 or 1. Okay. So one limit is from the x limit is from 0 to 1, and for y limit we have solved right now, that is x square starting from point x axis, that is this curve here, y equal to x square, and it ends at this curve, that is y equal to root x, right? So this curve is of x equal to y square, but we needed the limit of y, so that's why we have solved this curve for y. So if we do this part here, we would be getting root x as our answer. So the limits of y are from x square to root x. Okay, now we have got the limits here. Now put it in the formula and solve, that is double integration of dou n by dou x minus dou m by dou y dy dx, right? So let us put that. So outer integral I am putting of x now 0 to 1, and inner integral I am putting of y, that is x square to root x. So this we have solved it here, we have got it as 10y. Okay, write that 10y dy dx. Okay, first we should be solving the inner integral, the first integral. Let us solve that. 0 to 1, 10 you take it common, so y dy. So y dy is equal, the integral of y with respect to y is y square by 2, and the limits are from x square to root x dx. Okay, 0 to 1. So solve this. Substitute upper limit minus lower limit, that is upper limit is root x. So root x the whole square is x itself. Then we have minus lower limit, that is x square the whole square, that is x to the power 4 divided by 2 dx. Okay, I'll continue it here. 0 to 1. So we can solve it here, that is 2 1s are 2 5s are. So we are left with five x minus 5x to the power 4 dx, right? So I'll continue in next page. Zero to 1, 5x minus 5x to the power 4 dx. So split it, 5x dx minus 0 to 1, 5x to the power 4 dx. So 5 take it common, so x dx, the integration of x is x square by 2, 0 to 1 minus 5, again take it common, x to the power 4 is x to the power 5 by 5, 0 to 1. So if you solve this, you would be getting 5 into 1 by 2 minus 5 into 1 by 5. So cancel 5 out, so we are left with 5 by 2 minus 1, that is 5 minus 2 by 2, that is equal to 3 by 2. Okay, so therefore our answer is region of surface dou n by dou x minus dou m by dou y is equal to 3 by 2 according to the Green's theorem. Okay, so this is the product here, final answer. which we got for this problem. So again, go through this problem, guys, very important one. Understand each step very carefully and try to solve it by your own. Okay, so this is the answer, guys. Note it down. So this is the next question. So the question is, apply Green's theorem in the plane to evaluate the closed line integral 2x square minus y square dx plus x square plus y square dy, where C is the curve enclosed by x-axis and semicircle. They have given us the term as semicircle, and the equation for semicircle they have given it as x square plus y square equal to 1. Okay, so this is the question here. So according to the question, we should be drawing one semicircle, right? So let us draw that semicircle plot here. Y-axis, x-axis. So they have told one semicircle enclosed by x-axis. That is, the semicircle should be drawn with respect to x-axis. Okay, not like this. Should be drawing on semicircle like this. Okay, so just shade this whole region because they haven't mentioned any other points. Mark some points here. This is origin. So this point is 1, 0. This is 0, 1, and this is minus 1, 0. Okay, and this is the x square plus y square equal to 1, because the radius they mentioned it as 1, so that's why I marked it from minus 1 to plus 1. Okay, hope it is clear. Now according to the question, using Green's theorem here, m is equal to 2x square minus y square and n is equal to x square plus y square, right? So now what we should be solving for? Dou m by dou y, that is partially differentiation with respect to y. So here we don't have any y term, so here the differentiation is minus 2y, and dou n by dou x, that is with respect to x. Now this goes, we are left with 2x. Okay, so dou n by dou x minus dou m by dou y is equal to 2x minus of minus 2y, that is 2x plus 2y. Okay, or we can take common term 2 outside and we would be left with 2 into x plus y. Now let us write the limits now. Limits of x are from minus 1 to 1, as you can see from the semicircle. Okay, x limits are from minus 1 to 1 and y limits are from, consider this equation now here, x square plus y square equal to 1. So take y square one side to a single side, so we will be left with 1 minus x square, bring it to other side, x square. So if we solve for y, we would be getting square root of 1 minus x square, right? So this is the other end of the limit. But the first end, because it's a semicircle, so it is not plus or minus, it is the positive side. Okay, because it is bounded by x-axis, so this plane, this is the positive plane. So that's why you would be getting y is equal to plus square root of 1 minus x square, and the first starting limit is from 0 because it is a semicircle. So 0 to square root of 1 minus x square. Okay, so these are the limits of x and y. Now put it in the formula, that is region of dou n by dou x minus dou m by dou y dy dx, right? That is outer limits I am going to write of x here, that is from minus 1 to 1, and inner limits are from y here, that is 0 to square root of 1 minus x square, 2 into x plus y dy dx. Okay, so take 2 common here outside and minus 1 to 1, so x plus y remains, x plus y with respect to y now, so x into dy, that is x is common, so integration of dy is y, plus y dy. So y dy is integration of y is y square by 2, and the limits are from 0 to square root of 1 minus x square dx. Okay, minus 1 to 1. So substitute the limits of y. In place of y you put the upper limit, that is x into square root of 1 minus x square plus square root of 1 minus x square the whole square by 2 minus the lower limit 0, that is x into 0 plus 0 square by 2. Okay, so this it would be getting cancelled. We would be left with only this part, that is 2 into minus 1 to 1 x into square root of 1 minus x square plus, so root and square gets cancelled, we are left with 1 minus x square by 2. Okay, dx. Now what I am doing is, this part I am taking it as I1, this I am taking it as I2 and solving separately, okay, in order to make the problem easier. Now I1 is equal to minus 1 to 1 x into square root of 1 minus x square dx. Okay, now put the limits. Since square root of 1 minus x square is an odd term, right, so we can directly put the limits and write it as upper limit minus lower limit, that is 0 into square root of 1 minus 0 square sorry 1 into square root of 1 minus 1 square minus minus 1 into square root of 1 minus of minus 1 the whole square. Okay, that is 1 minus square root of 1 square is 1, so we would be getting 0, and here also square root of 1 minus square of minus 1 is plus 1, so 1 minus 1 you will be getting again 0. So here the final answer you will be getting is equal to I1 is equal to 0 because it is an odd term. Okay, so this corresponds to an odd term, that's why. Now let us solve for I2. I2 is equal to minus 1 to 1 1 minus x square divided by 2 dx. Okay, so what I am doing is I am taking 1 by 2 outside, minus 1 to 1 1 minus x square dx. Okay, 1 by 2 do the integration part, 1 dx, that is integration of dx is x minus integration of x square is x cube by 3. Limits are from minus 1 to 1. So do the upper limit part, 1 minus 1 cube by 3 minus of minus 1 minus minus 1 the whole cube by 3. Okay, 1 minus 1 by 3, 1 cube is 1 minus minus 1 minus 1 the whole cube, that is again minus 1, so we have already one minus sign, so plus 1 by 3. Okay, so I2 is equal to 1 by 2 into 3 minus 1 by 3, we will be getting it as 2 by 3 minus of, this is minus 2 by 3, so we will be getting 1 by 2 into 2 by 3 plus 2 by 3. So if you solve it, you will be getting 1 by 2 into, so denominators are common, so add the numerators, 2 plus 2 is 4, 4 by 3, 2 ones are, 2 twos are, so our answer of I2 is equal to 2 by 3. Okay, now our value of I is equal to 2 times I1 plus I2. Why 2 times? Because in the initially we have taken this as I1 and I2, but we have not considered this 2. Okay, so that I am considering here now. So I is equal to 2 times I1 is 0 and I2 is 2 by 3. So 2 into 2 by 3. So the value of I is equal to 4 by 3. Okay. So our final answer (4 by 3) units. Okay. Yeah. Hope it is clear. So this was the video, guys. We have solved 2 very important problems in this video. Please go through these problems very carefully, because these kind of problems would be appearing in the exam as well. So that's all, guys. In the next session we are going to see with some more problems. Okay. Thank you.